No way. Let's scoop it out. Cover the reactor. We need to film this.
Hello, my name is Dmitry. Welcome to the DPLABS channel. In this episode, you'll see the continuation of experiments with a turbine based on the organic Rankine cycle. Here we go. Well then, gentlemen, our test stand continues to assemble itself. This is how, like magic, we ended up with this contraption. So, what do we have here? Here we have, as you all saw, our steam heater. This is the steam separator. And now it already has a nice sight glass installed. Here the solenoid valve leads to the Tesla compressor, and after that there are more sight glasses. The non-condensed gas enters the heat exchanger. On this side, water exits from the heat exchanger. We have sight glasses everywhere. It passes through a filter. It enters the condensate pump. From the condensate pump, it goes through a check valve and returns to our boiler. As you can see, it's currently pressure tested at 30 bar. I don't think our pressure will reach 20 bar, but we'll see. We pressurized it to 30 bar. Everything seems to be holding. It's all sealed tight. Now we'll assemble a few things, connect the cooling water, and start the tests. Hopefully it won't, blow up. Look, we've got a ton of electronics hooked up here. We need to monitor everything we possibly can here. We've installed 2 meters. Basically, we've set up contactors that connect our generator to the load, which control the heating elements, and we've also got these devices hanging on Modbus with PT100 and PT1000 sensors, plus control relays. Everything's set up, and right now we're filling it with our wonderful R11 Freon. Right here we have, it's a bit cold, around 20 degrees, and this Freon boils at about 23 degrees, so we had to do everything by gravity, basically. Is it flowing or not? Well, judging by the bubbling, it is flowing. Through the sight glass, you can see how much has gone in. We poured it into a little bucket. So look, it boils at 23 degrees, and here it's a bit cooler. If I pour it into my hand, it starts boiling right in my hand. It's a pretty unique sensation. And actually, you could even pour it on a person and nothing would happen to them. Well, it's just supposed to be for extinguishing fires, I guess. Looks like the wooden beams have gotten dry or something. Oh, wow. What? It dissolves the greasy film. All right, yes. Well, yeah, we had to rig up quite a lot of stuff here, of course. But it's all necessary. Now we're going to strap on the sensors. And then we'll have a test run. We won't insulate it for now, but if everything starts up fine, since we've already pressure tested it at low DC, there are a lot of connections. So wish us luck. Anyway, we decided to experiment here. We brought in some liquid nitrogen. Here it is. We've made solid Freon, just like solid Freon, and that's how this nitrogen was formed on top. I won't stick my hands in there yet. It's a bit too cold. Let's poke at it a bit. Maybe we should just pour in some solid Freon directly. So let's carefully poke at the solid Freon a little bit. It's quite dry and rather airy, this particular solid Freon. Let's see, it's slowly starting to melt, the solid R11, and you poured in some more, right? Wow, just look at that. The visual effect from the Freon is truly beautiful. There are some really interesting and captivating vapors rising up. Yeah. Wow, it actually looks really nice. Yeah, that's Freon nitrogen.
A Dawn 222 with a flourish.
And this vibrant blue Freon snow, this is precisely what R11 refrigerant looks like when it's completely frozen solid. By the way, it's truly quite interesting. The consistency is actually kind of like, wow, it freezes almost instantly. It effectively absorbs heat very rapidly. Wow, that truly looked incredibly healing. The way the light seemed to envelop everything, or perhaps the gentle soothing movements, gave off such a profoundly restorative and calming energy. It appeared to offer a deep sense of comfort and rejuvenation, as if all worries and stresses were simply melting away. One could almost feel the positive effects radiating from the scene, promising a complete and utter sense of well-being and renewal. It was a truly remarkable and deeply therapeutic visual experience, suggesting a profound and beneficial impact on anyone witnessing it. Yeah, it'll be medicine. It should partially boil the entire barrel along with the water and the soda and also the soda. And why can't you use it as a foaming agent in rally, but you can do it like this? Well, gentlemen, it's already late in the evening. You're a bit tired too. Everything's closing. We're starting to fill up and we're beginning our test run. Basically, we poured in an unknown amount. Hopefully it's full. Turned it on for now. So-called, it's warming up. And as for the return valve, no, it's not holding yet. So that condensate doesn't build up before the system is warmed up. We closed the taps by hand, and through the sight glass we could see some processes happening because it was rising, then compensating, then flowing back down. Now we're going to build up pressure, I think up to about 5 bar, and start the test run. Look, we've connected all of this to my smart home system. Here we have this setup. Here you can see the temperature. Right now it's 54.8. And the temperature, here we can turn the valves and the condensate pump on. Anyway, it's all connected like this. It's convenient to control from the laptop, and you can log everything. We probably need a pressure sensor. Maybe we should install one. 4.20. Well, okay, later. How much is it now? 3 bars of pressure. All right, go ahead. Well, let it finish buzzing. Is it showing the temperature over there? So, gentlemen, we've tweaked the setup a bit. What did we do? We insulated everything thoroughly because there were major heat losses. We had to tweak the compressor, adjust the scroll a bit by about 10, otherwise it would jam due to thermal expansion. After that, we installed different inspection windows made of polycarbonate, but it started to warp. Now we're using borosilicate glass. And so we fixed up a few other things and made the stepped load connection. Right now it's running at 3 watts through rectifiers. We're loading the heating elements with direct current. They're over there in the bucket. So basically we're about to start the experiment. At the moment we have 80 volts, 1.5 amps, so a little over 100 watts. As you can see, I'm already producing. There's no liquid carryover. Everything's running without liquid. It's superheated steam. The pressure, what do we have now? About 6 bar, somewhere around 6 bar. It's starting to smell like something. Here too, there's no liquid carryover at the outlet. Everything is condensing properly. In the sight glass, you can see there's some condensate. Right now, R11 is charged about 25 liters or so. Anyway, we'll build up the pressure now and see what happens. It's gradually picking up speed on its own. Let's see how much we can get out of it at maximum. Well, right now it's working at, let's say, about 2% efficiency. That's already something. It's running, it's accelerating. Look, it's going 84 volts, 1.6 amps. Plus, there are some losses on the diode as well. Well, all right. Otherwise, our meter doesn't want to work at low voltage. It's showing something unclear over there. Something weird is happening with the scroll compressor. It's just... Basically, it's 170 watts of power right now. Less than 2% efficiency. Not great. We're going to shut down the setup because everything is vibrating here. No matter what it smells like, I don't want to get a face full of hot refrigerant. By the way, the refrigerant temperature is 110 degrees right now. But we won't push it any further. That's how it is, guys. It just runs like crazy with no load. 259 volts. Damn, guys, I don't know if you can hear it, but it's making a lot of noise. I wanted to talk about the instruments we're using here. This is a Modbus gateway. To Ethernet, this is a Modbus converter. PT1000. Here's another one just like it. This is a Modbus relay. Then we use all sorts of contactors. We use PT1000 thermal sensors, and we control it all with our smart home management system from a phone. That's it. Oh, and we also check where the meter is at right now, how much electricity is being used during operation. Right now, by the way, the heating element is off, and our system has a lot of inertia. it will take a while before it cools down. It makes a lot of noise, but it doesn't really do much. So, gentlemen, what conclusions can we draw from this wonderful porno film that just took place here? Well, this device produces just over 10 watts, which is about 2% efficiency. But as we can see, it doesn't work very well as a heat engine. Overall, the whole setup works and confirms the theory. Yes, this turned out to be an installation based on the organic Rankine cycle. So, what are we going to do next? I don't think we're going to abandon this project. I'll try to get a piston expander, which is used in air liquefaction systems. It has a mechanical efficiency of about 65%. Well, it's a big piece of equipment and it costs money. But we'll try to get it and experiment with it. Or we'll try to build it based not on a scroll, but on a screw compressor. I have a screw compressor that we can take apart, because industrial installations like this are usually built using screw pairs. So we'll see what happens. This isn't the end yet. Well, folks, I hope you enjoyed it. Subscribe to the channel and leave a like. See you soon.
Bye.
And so that in the end it would be like this. Bam! To the other one. Just like this right now. After the test, this stand could easily be used as a pretty decent moonshine still. Everything you need for that is here. And we've got a pretty good condenser. You unscrew this, and in this slot, there's a drain right there. Basically, everything's as it should be. The camouflage tastes good. It kind of, well, smells like something weird. And it's boiling in my hand. Look, because my hand is hot. See, it's starting to boil. I can really feel it. My hand is getting covered in some kind of gunk. I hope this is safe.
Huh? Shall we go?
Oh, let's start. Can you see anything? There definitely wasn't any sound or anything. Wait. Yeah.
It's completely jammed.
Let's try again. Hold on, let me do it. Don't laugh, you look so serious right now.